All right, Claire, you want to kick us off?
Would love to. Morning, everyone. Hi. Those that don't know me, hi, I'm Claire. Along with Wes, we are your co-chairs. Welcome to another IETF Secure Asset Transfer Protocol meeting. So a bit of formality to start us off with. Obviously, the note well, the IETF policy is in place. We agree that this is not covered by patents. We agreed to attend the written audio and video photographer. It's 6 a.m. here. I've been up for about 20 minutes. I do apologise. Photographic records of meetings may be made public. Personal information will be handled, and so on and so forth. Links to the standards processes and the working group processes. I'll leave that up for a minute for everyone. Code of conduct guidelines, obviously treat everyone with respect, speak slowly and limit the use of slang, use reasoned argument, use best judgment, find the best solution for everyone and the whole internet. And that's something we really focus on here, is making sure that our approach is agnostic, and then just contribute to the ongoing work. This session is, of course, being recorded. Make sure everyone's signed in using the tools. I think everyone here's been to one of these before, so should know your way around, but I'll leave that on screen for a minute. Just make sure that everyone is aware of what needs to be logged into. And the working group information. We have 3 active drafts to consider, or 3 core documents to consider. That's the core, funnily enough, architecture and the use cases. And we'll hear an update on those today. Agenda today. So introduction, hi, here's us again. Call for note takers.
Ori and I are going to try and handle it together.
Very kind, thank you very much. Working group document next steps. So we'll go through sort of a bit of a process. We'll show you sort of where we are in the process and what needs to happen next. Wes has kindly reviewed the documents as chair and has some feedback for us. So he'll go through that. Then we have the recharter goals, which I know is an exciting topic for all of us in terms of where we're going to go next. Thomas has asked for time for a stage 0 discussion, and then any other business. So even if you haven't messaged in the email thread, please do feel free to bring any other business to the table at this point.
We actually do have one more. That slide's a little out of date. There's going to be a SATP implementation guide proposal from Haojun Song. So he's
there
actually
is.
in the room.
Yeah, thank you for reminding me. And then this is the process flow summary in terms of the documents and what takes a document to get to published RFC. Wes, did you want to talk to this?
Yeah, I'll go ahead and talk to that. Thanks. So this is actually stolen out of brand new training material from that was given on Sunday. So a tutorial on how the IETF works. And it's a really well put together diagram. The executive director of the IETF sort of helped spur this forward. So essentially, we, have gone through the process of having an idea, creating a bunch of documents, creating a working group, calling for adoption. Right, the documents have been adopted quite a while ago. The working group worked on that. It went through working group last call, some of them twice, which happens all the time. And then that's where we are, right? We are right there. We're right before submitting it to the IESG. Many people have asked on the mailing list, what happens next? So once it gets submitted to the IESG, Ori will take care of that. Sort of missing in that bubble is we have a shepherd that will write stuff up. Peter has volunteered, as has, we actually will probably split the work because you volunteered as well. So thank you for doing that. The AD will review it, and he will be more nitpicky than I will, just to warn you. At which point, it may need to be edited again. I will already tell you we need a couple of edits as well. And then it'll go through IETF-wide last call. So the working group last call in the 3rd line is different than the IETF-wide last call in the 5th one. That we will get a lot of feedback, period. We get reviews from all the directorates, from the security directorates, from the DNS directorate, from the Gen Area directorate. Lots of feedback will come, as well as anybody that reads it from the larger community as well. That will likely cause yet another round of edits. So if you think edits are done because we're through the working group, you're unfortunately wrong. And they're sometimes large and we'll need some talking about in the mailing list. And then finally, the IESG will review it. And so they think about it from the perspective of all the different areas. That is the engineering steering group's purpose, right, is to review it and make sure that, you know, from all of the different areas of the IETF, it looks solid, robust, and is not impacting other protocols and things like that. And then finally, it's sent to the RFC editor. The RFC editor will find yet more typographical and little mistakes that all of us miss, because that's their job and they're really good at it. After getting through the rest of those reviews, they still find wording suggestions. And then finally, to be published as an RFC. So that's where we are at this point. So at a high level point of view, I did a chair review after seeing what the working group put out, and I have some comments that I'm going to talk to in a minute. And then the Shepard write-up already talked about in the area drift review and the IETF wide left scope. Those are the big, out of that flow diagram, those are the big four things. They will trigger some updates possibly. I always love tab damage produced by exporting slides to PDF. And then the other thing we're going to do today is a charter discussion. We'll come back to that. So I'm going to dive first into sort of my thoughts on doing, you know, a review from being a very nitpicky chair looking for things that we might need to change. I need to stop slide sharing. There we go. Share slides. And all right, so this is the results of me really getting my critical pen out and looking at the documents that have come out of the working group. And I did this once, you know, I think a year ago as well. Let me pass slide control to the clicker. So are the documents ready to go? I got some good news and some bad news. The good news is they have come so far. Though when I read them a year ago, I didn't see how somebody could even understand the flow and implement them. So the working group authors, the working group participants that helped put it together, as well as the authors, you've done an excellent job. But you know, there's a shoe to drop, right? So the bad news is, in my, you know, fairly nitpicky review, the way I went into this is I looked at it from a, can two independent implementations sit in a box completely isolated from each other and come up with the same implementation of the protocol that can actually interoperate? And so I found a bunch of small things. Those are trivial. I'm not going to go into them today. I'll write them up and send them to the mailing list later. And then, but there was two larger problems, and this is really with the core document. One is some encoding format issues, and two is a list of acceptable values, which I will dive into what those mean. So from the encoding format kind of point of view, this slide's a little dense, I apologize, but when you have values, regardless of, we know that everything's going to be put into a JSON structure, right? But there's many different ways to encode things. So for example, for the originator public key required field, right? This is a public key of the asset owner originator in the origin network system. Great. You know, I can understand what that means. I love the fact it says it's required, because I know that I have to put it in there. Everything is nicely marked optional or required. But I don't know what that encoding actually is. Like, you know, what is the contents of it? There could be many different ways to encode it. It could be base 64. It could be hex. To me, it looks like hex, but technically it could be either, right? There's no definition of even what that hex encoding is actually representing. Is it representing a dir encoded cert? Is it encoding a cert? I don't know. And so that makes it very hard for me to figure out what it is. Now, I note in the description that says it's required, it doesn't talk about the encoding at all. And that hex code is only in the example. So there's missing information for me as a implementer that has never read this before to figure out what I'm actually supposed to do. So that needs to be looked at for each one of the core fields entirely, right? So the second one is sort of what I call the list of acceptable values. Sometimes you have fields that have, you need to put an integer in here from 0 to 2 to the 32nd or whatever it might be, right? That's fairly obvious that it just needs to be this big thing. Other times, however, you have a list of acceptable values. So the network lock type, which is required, is a good example, right? It's the default locking mechanism used by a network. And it can be, and so you listed 3 examples: time lock, hash lock, and hash time lock. Great. I would have picked one of those 3 exact strings to go into, the field when I was encoding it into JSON. When I look at the example, it's all caps with underbars, hash time lock, right? That does not match what I would have, likely guessed from the single string. And there are other fields that don't even have a list of values. So, the reality is all of the various components need to be thought of for when there is a limited list of possible values, like an enumeration of some kind. What is the list of acceptable values? Because otherwise, I may put in hash time lock with no spaces and all lowercase, and Ori may put in hash time lock in uppercase, and we're not going to interoperate, right? So that has to be fixed as well. And there's a few things that we can do here. Remember that this only applies to fields with a limited number of values that we'd have to agree on what that means. So the list of options for like going forward here, there's really 3. For each field, there are 3 different possibilities. You can list all the acceptable fields in the document. You can point to an external list of acceptable values, like, it has to be a cryptographic algorithm on the NIST list or whatever. Or we could create an IANA registry table, and I'll get to that in a second. For, that's actually, you'd point to the IANA registry table. So when would, that is not the newest version of the slide. All right, so let me dive into what each of these mean, which is really what the other slides really added. So for the list of acceptable values, if you have a field that has, for example, the 3 different lock types, you can list them. They've got to be very explicit, exact encoding, right? Put them in quotes. Bullet lists work well. Some way to say these are the exact strings or numbers or whatever it might need to be. You can also point to something external. So as I said, if you want to point ideally to an RFC that where all of the strings are defined, right? You want to pick something out of, this other list. The HTTP response code is a good example for that, right? You actually do that in one place as well. And then finally, an IANA table can be created, and typically we would want to do this if we expect multiple other standards or multiple other documents to need to add entries to that list, right? It's not just going to be maintained in the protocol document because it's some sort of generic field where maybe every owner of an asset network might need to insert a value or something like that, right? That's something that would be extended, but everybody would have to agree on the right value to pass around. That's a great place for an IANA registry table. If you think you're at that point, this is to the authors really, if you think you're at that point where you need something that requires an IANA registry table, we will have to, I can help you work through that basically. Right now, the IANA consideration says TBD, by the way. That's not actually quite sufficient. You don't have anything, right now. So I hope that all makes sense. I would love to hear if, especially the authors or anybody in the working group has questions about everything I just said. Thomas.
Hey, folks, can you guys hear me okay?
Yes.
Okay. No. I think I agree with Alex there that you're spot on. we're looking. Alex sort of remotely looking at each other and said, "Yeah, we kind of didn't list certain things. The hash lock situation, absolutely right. So there's at least 2 or 3 versions of what a hash lock is, and so we need to just enumerate what kind of locking technology is being used by a given network. I had a sort of question, was so you're saying we create IANA table, like where would that table sit, in our document or some other document?
Excellent. Good question. So 4 places where we need an IANA table, which again is really only if we think a lot of entries need to be added and we're not going to maintain it just in the course specification, because it's a work to do. You actually do create it in the table and in the document. And in the IANA considerations section, we would advise IANA, we need to create this registry. Here's the restrictions for how stuff can be added. Does it take a standards document to do it? Can anybody do it? Is it first come, first serve? And there's a list of types of things. There's a whole RFC, of course, about how to do that. And I can help you do that, but we don't need to do that live here. So, but really get the notion in your head of when it's required or when you need one versus when you don't. And when you need one, we can work through that. Makes sense?
Yep. Okay. Thank you. Yep.
Yeah. So do note that the examples I put in these slides are just examples. Unfortunately, every single field needs to be looked at again, just one more time. Some of them, it's going to be obvious, right? There is a session ID. It's created by, the client. Nothing needs to go there, right? It's a unique string. They can put in whatever they want because the receiver is just going to echo it back at some point. It really doesn't matter. But there's a lot of fields where that's not the case. Make sense?
Yep. Okay. Thank you.
Anybody else have questions or comments? Alexi.
Hi, yeah, I just wanted to say thank you for all the feedback. It's great stuff. And yeah, for the IANA table, there are currently 2 implementations that I know of, at least for SATP, one by Quant and one by Hyperledger Cacti. So we could maybe chat and see if the IANA table might be good to have even now. So yeah, we'll come back on that.
Well, so what in your implementations needs a unique value that would need to go into a table, right? As opposed to the document telling you guys that the 2 implementations, this value goes into this field.
Yeah, I guess for the locks, there could be just multiple types in the future. So maintaining it externally to the document might be a good idea.
Okay, that's sufficient. So, I mean, I don't have an opinion myself. It's whatever you think. If you're going to need a lot of new values in the future, an IANA table is absolutely the right thing to do, period.
Okay, gotcha. But yeah, anyway, thanks for all the feedback. It's great stuff.
Absolutely. Peter?
Yeah, hi, this is Peter from Huawei. Actually, I'm here a little bit late. I don't know if we already covered the Shepherd part because, when we going to the Shepherd part, I kind of volunteered to the Shepherd write-up and taking notes and everything you said. I would be working closely with the chairs. I think Claire responded that with email, just like telling the team everything, publicly. Actually, there was one problem because I volunteer for shepherding all these 3 core documents, and I think Thomas and I kind of contributed enough content and content with Thomas to be part of to be an author of the use case document. So I don't know if there's an issue.
Yeah, typically the author shouldn't. The good news is Haojin actually offered to be a shepherd as well.
Oh.
So we were already going to split things up. It'd be good. It's good for anybody to learn how the IETF works, to sort of go through that process. So Clara and I will talk and sort of divvy up the load. And so,
Cool.
but
Wonderful.
certainly I think the use case document will definitely go to Haojin. So that's my guess. So,
Wonderful.
yep. And thank you for doing that. So. All right. Any other questions before we go on? All right. I see none. So let's go back to the list of, so on the agenda next, we were going to talk about rechartering. There's a condition to this. The existing documents have to get done first, right? So we can go on to what we're going to do next, but work on the existing documents has to trump anything new. So when we get feedback from the AD, when we get feedback from the ASG, when we get feedback from the IETF community, we need to act on it. And that has to stop sort of progress on anything else that we agree to recharter on. Does that make sense? Okay. So what I think that what I want to do here is we're going to brainstorm a list of things that we know we need. And I will share my screen and we'll do sort of some live editing to start documenting that list. Ori and I talked earlier this week about what we should do for rechartering purposes and how big the charter should be and things like that. So my plan is let's brainstorm on a list of things we know we need. Then afterwards, we'll prioritize them a little bit to figure out what do we need first, right? I think the obvious one is stage 0. That's been talked about for 2 years at this point. So 1 second while I find the right screen to share. I'll share the entire screen. Cursive editing, screen sharing is often a little bit slower, but basically we're going to come up with this list. The other thing to know about rechartering is Ori even agreed we could list a lot of things. We should only work on a couple items at a time, and we can say this is sort of the order of priority in it, but we don't need to recharter again really quickly if we get a bunch of stuff. And Ori is nodding at me slightly, so he hasn't disagreed with me yet. So with that being said, so let's, I want to take, and Claire, can you moderate the queue? I can't look at 2 things at once.
Absolutely, yeah, no problem.
Thank you. So let's start, right? So I know that there are some stage 0 negotiation types of things, right? What is it that, how do you bootstrap the discussion that you're actually going to start a connection, right? We've talked about bill of lading type of stuff. I know that that has been in there and that requires some things that the current protocol doesn't support. And I know that we have bidirectional transfers, right? Sort of exchanges. And that's just, I'm throwing out some examples. Ori, please.
We have a hand up from Ori.
Hi, Ori Steele, your AD, friendly AD. I just want to know, for the rechartering conversation and also for the documents that are about to come to me, one of the main things that we're going to be looking for is in multiple independent implementations, interoperability. We really want to know that the specifications, proposed standards that you guys have developed together, that you validated that these are interoperable, that they work, that they achieve, that they solve for the problem that they're targeting. So as you think about this list, it's really important that you think about, are there going to be, multiple parties that will implement, for example, the bill of lading scenario. So, directly, if there's only one organization that's really interested in the bill of lading scenario, and there isn't going to be an interoperability opportunity around that particular charter item, that's going to raise my eyebrows as your AD. It's not to say that, we can't, have a conversation around that or, figure out, what are the constraints around the bill of lading, extensions that might need to happen. But I'm going to be looking for support for these charter items from multiple parties. And I'm also going to be looking for scenarios where you need interoperability as opposed to just needing to describe something internal that wouldn't necessarily need to be described within an IETF proposed standard because it might live within, a single software boundary. So I want to say all that now as we go through this list, so that as you come up with these items, you're considering items that meet that bar before you look at other items. Thanks.
Very good point. Thank you, Ori. I took notes for you. All right. So who wants to add things? Bing?
Bing Liu from Huawei. I would like to propose, I noticed that in current document, we actually wanted to address another scenario rather than the asset transfer, which is data sharing. But the current protocol doesn't really deal with that kind of scenario. So maybe I think from the scenario description, gap analysis, we can figure out maybe reuse some existing mechanism. Maybe we'll need to introduce some new technology for this kind of scenario. Yeah.
Right.
Thank you.
I missed one word when you said sharing. Did you asset sharing? Is that what you said?
Data sharing. Yeah. Data
sharing.
Yeah.
Oh, right. Okay.
Thanks.
So I think there was multiple things surrounding that concept. The other one is how do we attach metadata to existing transfers, right, to indicate additional context surrounding a transfer. Yeah. All right.
We have a few people in the queue remote, so Thomas is next.
Folks, yeah, could you guys hear me? Probably, as you'll see later on in the presentation, we need to, I guess, define what an asset ID is. Like if there's a tokenized asset sitting in a network, like does it have its own unique ID and so on? And related to that is the network identification. Right now, there isn't, people just loosely call, oh, it's Ethereum, whatever, this particular network, but there's no encoded way for code to actually process it from outside the network. So this is part of the draft that Weija was working on that's expired, but the problem's still there, and it's on the to-do list. So I would add that, and also and Dennis can speak to this, some kind of a transfer context data structure definition. What does it look like? And then secondly, how do you arrive? How does both ends arrive at a common transfer context establishment? What's the data items that goes into that transfer context blob?
So in all of those, Thomas, those are all part of stage 0, yes?
Yes, that's right.
Okay.
Yes, I like breaking apart stage 0.
Okay, that's fair. Then I'll do that. Thank you.
Thank you, Rama. And then we've got Dennis after Rama as well. Oh, we've got quite a list going.
Hey, so just responding to the question about data sharing. So the term data sharing is kind of ambiguous, but we mention it in the architecture document as an interoperation mode where you need the ability to address and request and acquire ledger state from a different ledger, or a network state from a different network, if we put it in network terms. And the concept is fleshed out a bit more into candidate drafts that I've talked about several times. One is on requesting views from a different network, supplying views, and then describing the request response protocol, through a pair of gateways or either a single gateway or through a pair of gateways that can fetch you a view. So I'll also mention that in in Thomas's presentation later on. This concept can also be used potentially in stage 0 and maybe also in latest in the within a SATP core session, if say a session's crashed and you need some information about where the other network is at. So.
Right. Okay. Thank you. I remember the discussion about how to deal with views into another asset network in order to identify stuff. So that makes sense. I grouped metadata and data sharing together because I think we're sort of talking about the same thing in those two cases, if I'm understanding it right. You guys are the experts more than me, though.
So I'm going to jump in here on that one. Possibly separate them. There's been a challenge come up where you can share metadata when attached to an asset, but then data sharing as its own asset almost should be considered as almost a subset of that.
Okay. Thank you for that clarification.
No worries. And then sorry, I definitely not the key to say that. And then we have Dennis next.
Sure. Good morning, everyone. Dennis Avrillionis from Compellio. There is one underlying concept, stage 0 data sharing and eventually metadata. It's what we were discussing also in the mailing list sometimes about all the artifacts that are around SATP. So all the things that are necessary in order to execute the protocol. So there is this concept of registry that used to be called also API 3 in the past. So there is a construct that needs to maintain information about all the things related to a proper execution of SATP. That includes asset IDs, network identification, context, eventually metadata, and other things that are required for the protocol to run. So that's one thing. The second thing that I believe it's important also is to define some requirements on the network side. So we usually talk about locking, eventually rollback. So these are primitives that the networks at some stage should support. So we have to define the minimum requirements for networks to participate in SATP. And I believe that this should be a different. So two things: the registry that might require a lot of things from stage 0 to be there, and also the network requirements.
Okay. Thank you. I know we've talked about network requirements. I thought some of that was actually in the architecture document at this point. But, you're right. It's not a definitive list. How you?
Hyojin?
Yeah. I'm Hyojin Song from Seoul National University, and I'm gonna present the SATP implementation guide a few minutes later. But and I'm not sure, but it could be covered as an informative draft on the rechartering discussion. So I would propose it as well on the list.
So an implementation guide for what's required. That's a good point. I'm going to put that sort of underneath requirements, or maybe I'll merge these together, right? Because the requirements for a network, I guess they're different. Never mind. So an implementation guide for
peer gateway, or
right. Okay.
Okay.
Thank you. I will note, as or even indicated earlier, this is the brainstorming list. This is not necessarily what will definitely be in the charter in the long run.
So I put my hand up this time. I put my hand up this time. So a couple of things to mention. A point to note on point 10, requirements on the next network side and a minimum list of requirements. Can I just clarify, is that a minimum list of requirements on the network, given that we said we would try, one of the main things was that we should be network agnostic, and should it be instead commentary about the minimum requirements of a gateway? Something to think about. Did we also want to discuss the requirements of a gateway, given that that is gateway to gateway? It may be covered in the implementation guide. And then one to mention from David Millman in the in the chat channel asking if we need a separate document describing the threat model. And I think everyone else's comments in the channel have been brought to the mic anyway.
Okay.
So I'll step aside and let Mike go.
Yeah, Mike McBride, Future Way. I'd second the implementation guide suggestion. Some working groups shy away from a deployment type of submission or addition to their charter, and some working groups include like deployment type documents. I don't think there's an ops area that takes SATP into consideration, which would be helpful. So barring that, and whether it's in this charter, your list is long, so it's not likely to happen. But in the future, it would be really helpful to be able to see some sort of a deployment guide that shows how do I do something like transfer assets between Ethereum and blockchain, for instance.
No, that is fair. This, the work in this group is new enough that there isn't enough information out there. So anything helpful is beneficial. You're right that in a lot of the rest of the technology, something's up and spinning. We do roll out like an ops area kind of, thing for maintaining deployment and best current practices. We don't have a best current practice because there's no practice yet, right? So good comment. Thank you. All right. Looks like the list is empty. So I think this is a good list.
Very good list.
What, Claire?
It's a very good list. Rama's just put a large body of text in the chat. Was there anything else? I say large in comparison to the rest of the chat. Was there anything else to add to this list, Rama? Or was this just sort of a side conversation about one of the items?
No, this is just about the comment about where the requirements should be on the gateway of the network. Just a side comment.
Yeah. So, I think in the past we've discussed that a little bit of it's the thing using the protocol that has to be able to guarantee certain things. And I think, Claire, your comment was wise that as long as the gateway can promise those features, we don't necessarily need to impose it on the network. And there may be different ways to implement it depending on the type of network. In some ways, the gateways, we've talked in the past, could take ownership of an asset. That's a way of locking it, right? Peter?
Indeed. Sorry.
Yeah, this is Peter from Huawei. This is a clarifying question about asset ID. So is this about a negotiation of asset ID or a standardization of the structure of asset ID? Because there are many outside like there are different standards, like how do you structure a piece of data asset or just a piece of data like DOA or anything. So this is something I would like to know about.
Thomas, did you want to answer that?
Yeah. So no, good question, Peter. So there is currently no standard that could say, here's a bit of string that identifies this particular asset. It could be the header of a block somewhere on the ledger, right? Or a hash of it. And this happens to be sitting in that particular network, whether it's, Ethereum or, Avalanche or whatever it is, right? So this was part of the discussion with the wages document. Even within Ethereum itself, there was lack of the ability to do incoming cross transfer. But I think we've got some semblance of a draft for the network ID bit, but yeah, the asset ID that's wide open. I don't know how to standardize that. So, yeah. But if you have any ideas, that would be good.
Yeah, it's just this is just initial thinking of when you're really negotiating asset IDs, there should be maybe like a two-step process. Like you have to negotiate like what specific structure or kind of thing like of this asset ID, and maybe that's the first step, and then you will have the specific what asset ID you're trying to transfer. So as far as I know, different structures there are different structures out there, and yeah.
Yeah, so let me offer that right now we're coming up with a list of things we need to agree on. We could dive down into the rabbit hole of each one of these as what's needed, but
Yep. Sorry.
I think you guys have just proven to me that, you know, a discussion around what an asset ID is and how to encode it is critical. So.
Yeah. In general, the stage 0 pre-negotiation is important, I would say.
Right.
Yeah.
Yeah. So. Dennis, right?
Yes. Yeah. Yeah, I have a comment on the network versus gateway. I mean, the way that things are managed in general is that networks exist, and then we came up with a gateway as a means to transfer assets among networks. So there is a fundamental assumption in general in the distributed transaction processing that networks don't know about gateways and gateways know about networks. So if in terms of robustness of SATP, we would like to be able to say that if arbitrarily a gateway can pull out from a transfer at any moment and roll back, then all the management of the locking and eventually reversing in the middle of the SATP transfer should be put on the network. In that sense, it is interesting to be able to define some minimum requirements on the network and not on the gateway, because at the end of the day, it's the network that manages the assets. So that's one comment on the minimum interface that we may need for the network. The other thing is about the asset identification. There is an addition to all the work that has been done so far on the definition of assets, is that precisely in SATP we would like to move things from one network to the other. So there should be some meta description of what a pointer to the asset is, including the ID, because the asset lives inside the network. So we need to be able to track the asset when it is transferred from one network to the other. So we maintain unicity and we don't have duplication or loss of assets in this whole transfer thing.
Okay, thank you, Dennis. I will read that as support for needing the stage 0 items 1 and 10 both. Again, we're not going to dive into solving these problems today. It's what is the list of things that we need to talk about? I think it's clear that those are definitely some. I think this is probably a pretty good list. I think the queue is empty. I don't think we'll try and prioritize now. I think Claire and I will talk next week about the right way to bring this list to the email list, and then what we'll probably be looking for is a sentence description of what each of these means, and then we can talk about how to put them into a charter based on I think what the discussion on the mailing list of what the most important things might be. So rather than try and figure out that reordering today right now. Anything you want to cover, Claire? Otherwise, I think we can go on to Thomas's presentation.
No, I think that's good. I think that's a really, really valuable exercise. Thank you, everyone, for your contributions.
Okay, thank you. All right, so I think that brings us to the next agenda item, which would be Thomas.
Okay. Do you want to share slides, Wes, or should I try?
So I will start the share if I don't lose my browser window, and then I can pass you slide controls. So they've actually improved that quite a bit. So share slides, Thomas's stage, and then you should see a pop-up right about now saying you're going to take slide control. Does that work?
Okay, yes. So I'll move it forward here, arrow to the right. Did it? Okay. Nice color diagram. We like color. So this is intended to be a background discussion for folks who may be new and wonder, like, what are these guys talking about when they talk about network address and asset IDs and so on and so on. So the work, the three current documents that is making its way through is the yellow bit there, which is the actual unidirectional transfer. And what we're trying to figure out now is, well, before you do a transfer, from gateway 1 to gateway 2, we need to figure out, well, what are the information that is needed by gateway 1 and gateway 2 to finish the yellow bit, and whose job is it to actually collate that information and verify the information. And we've been using the application, the business application, as sort of the starting point, thinking that in reality, in many financial institutions, it's really two people using an actual application software doing stuff. Send to Dennis, in some other network, for example. And so the question is, how does this application app 1 interact with the gateway, and how does it interact, if any, to the network itself, right? And so you'll see later on, Dennis has got a sketch of how this is going to work. But this is where we are. So when we're talking about stage 0 or setup phase, we're talking about the blue bit, right? And it's going to involve messaging flows between the applications, app 1 and app 2, and it's going to involve messaging or flows or interactions between G1 and G2 as part of the setup. Okay, and we can come back to this document, but this only shows the left half. The other half is the same thing. It's just a mirror reflection. So this is some of the open challenges. Actually, the list that Wes has just written up, it's actually longer than this. But I thought let's talk about something that that's common. We've been discussing this at least a year on the mailing list. So context ID is one of the big things. So in SATP core, you'll see that for every transfer session, there's a context ID number that is used to create the actual transfer session unidirectional. And so the session ID could be a hash of a number of things. It's defined in the SATP core, but we haven't yet talked about what goes into the context ID. What do the applications need in this data structure, this JSON sort of blob that we've been calling context ID? Peter, did you wanna jump in?
Sorry, I just want to jump in, Peter from Huawei. Actually, about the context ID you just mentioned. So actually, there are when we see there are many different similar systems that are trying to do that actually are figuring out this context ID, like what should be inside of them, because like we see there's like international data spaces or happening in Europe. They're trying to define or kind of decide this context ID about how we are going to use this piece of asset or this piece of data as an asset. So these will be nice inputs or references. Either we reference them because in general, this context ID in their context is describing how these assets should be used or should be used in general. Okay, so either we reference them or maybe look at them and avoid stepping on other people's feet. And I that's just some inputs from context ID.
Thank you, Peter. Great. So the next thing is this asset ID. So this is a generic question. So if using say the European Union MiCA regulation as an example, they recognize what is called an asset reference token. So the token itself is referencing, say, a physical asset that's off-chain. That's fine. So leave that aside. So if you do have some kind of a token in network 1, does it have an ID string that could be referred to by the applications? And in fact, it could be even referred to, in legal documents if you wanted to do that, right? But it's referenceable, referable, so in network 1. And so if it's moved to network 2, does it keep the same ID string? This is a discussion. And then in the future, it's moved to network 3. Does it keep the same ID string? What's interesting here is that, of course, the network address is going to change. And initially, it was at network 1, and then it's not network 2. Now it's in network 3. Does the asset ID have like two halves? The front bit doesn't change, but the second half changes depending on which network it's on, and this is part of the requirement when we do the SATP transfer. The asset requirements sort of imply that you can only have one unique instance of this thing anywhere on the planet, right? If it's a token referencing, say, a unique asset somewhere, whether it's real estate somewhere, so this is why this question of asset ID is coming to the forefront, right now. Wes?
Yeah, so I mean, it's an interesting problem. So a couple of thoughts. One, doesn't this impose a requirement itself on the types of networks that can contain an asset have to be able to somehow attach that global identifier, within their network, which may or may not be possible depending on how they store data or maintain data.
Yep.
And then two, is there a security violation when that is not properly maintained and an asset, changes its identifier within that network because of loss of data or, intentional malfeasance or something?
No, good question. I think, and people can jump in here. I think, at least in the DLT-based, blockchain-based networks, there are already sort of common ideas about representation of an asset. So it could be, a hash of a header block, that or the actual, hash of the entry itself in the network. It's more like nobody's thought about this at a global scale, right? Because part of the interoperability challenge is seeing the bigger picture versus just focusing on my own blockchain and so on, right? And this is exact same problem is being reflected in the network address, that it's a recognized problem, but people are slow to address it because people are not looking at the bigger picture. This is part of the whole. I mean, we want to fix this for the whole internet, for the whole world. So this is sort of part of that.
One of the things we've learned over years in the IETF is that hashing algorithms are not permanent. So
yes, that's another good problem. Yeah, Dennis.
Yes, I wanted to add on what Thomas said, on the fact that indeed, I mean, any system, any network, because, okay, network, we use the term network, but behind that, it could be also traditional systems like Web 2 systems with databases and 3-tier applications. So any of such systems have a form of locally unique identifier for their assets. Could be a record ID, could be a UUID, could whatever, but it is specific to the system or network. Now, also DLTs definitely have things to address, like for instance, smart contract addresses that could be used as one reference where the assets reside inside the smart contract. So the idea here is to make sure that we can define something that universally address an asset, an address of the asset, as Thomas said in the previous slides. So that's the point of this asset ID. Should be a global ID that can track the asset no matter where it resides inside any network. So that's my comment here.
Okay, thanks, Dennis. The other thing is this, provable disablement. So what that means is that, and this is just in the local context, app 1, network 1, gateway 1. So you'll see in the next slide, and Dennis will go deeper there in the flow. There's a point where the application says to the gateway, okay, before I signal to application 2 that we want to proceed, can you make sure that the asset is disabled, locked, and the state is not changeable, in network 1. And so I've been using the word disablement, but how does Gateway 1 deal with that? We seem to think that's probably even out of scope for IETF, because there's so many different networks, ledgers, systems out there that it's really up to the gateway operator to figure out, well, how do I implement functionality to talk to this particular network, to do this particular locking and so on, or at least to verify. And this is where Rama's going to talk about this later on. We've been calling it views, but how does app 1, for example, verify independently that Gateway 1 has indeed done a proper lock? And so this is a separate, I would even call a separate protocol, just to check the state of a particular asset in network 1. And then lastly, standardizing APIs, but we could move that later on. This is APIs to talk to the gateway. And in the architecture document, you'll see us talk about API 1, API 2, and API 3. It's kind of confusing, but we're just needing better terminology. Dennis, did you want to jump in here? And folks,
Yes, sure.
I would recommend downloading the PDF and expanding this on your screen, because this is kind of small diagram.
Yeah, I have to zoom in it. Okay, so yeah, this is an attempt to define a potential flow of information between the various items, that appear in the architecture, in the core. So we have the client, we have the network and the gateway on one side, the outgoing side, and the incoming side, we have the gateway, network, and application too. So this whole game in stage 0 is to make sure that all the different elements come together in one construct that we call context. So we talked about the context ID before. Here is more or less what do we need to put in this context to make it immutable and universally referenceable by gateways. So when there is a specific transfer instance start, then we can go and get all the information that is necessary, either for the gateways to eventually restart if there is a failure or not, and also to keep track of what happened in a specific transfer instance. So in this flow of course, the flow starts by a client. So Thomas wants to send an asset to Rama, which is in the client application 2, for instance. So the very first thing to happen is that to declare the intention of the client application 1 that it wants to start the transfer using gateway 1 for network 1. So the very first thing to do is to go to gateway 1. So it's number 1 of the flow here, and say, okay, I'm client application 1, and I would like to start the transfer. So the gateway will return to a context. Basically, it would define a context with a specific immutable ID, and will give it back to the client application. So then the client that owns basically the asset on the specific network will go and say, okay, there is a transfer. I have the intention to make a transfer, and I would like to transfer these specific assets. That's where the asset ID come into play. So there is this number 3 binding of the asset to the specific context. This is important because in some implementations, we might have competing gateways over the same assets on the same network, for example. So the network should understand that the specific assets need to be transferred in the specific context between the two gateways. But as we are now in number 3, the gateway 1 doesn't know about the gateway 2. So after the operation of binding the assets to the specific transfer context on the network, number 3, then the client should make sure that this is transferred over as a transfer to the target client. So it goes to Rama, Thomas goes to Rama and says, okay, look, I would like to transfer the specific assets for the specific context. So that's number 4. Now, same thing on the application 2 side. When this propagation of context from one client application 1 to client application 2 is received by application 2, then the application 2 should go to the network 2 and say, okay, I am prepared to receive assets from network 1 and eventually prepare network 2 for receiving the assets. Now, once this is done, then the application 2, we are in flow number, message number 6, application 2 should go to the gateway 2 and say, look, there is this transfer context, so go and talk to gateway 1 in order to establish the context between the two gateways. And that's what is done in number 7. So the gateway 2 goes to gateway 1 because in the context there is reference to the gateway 1, and there is this binding between the two gateways for the specific transfer instance. And when this is received from gateway 1, then we close the loop and we go back to the client and say, okay, now all the elements are connected, networks, gateways, on one and on two side. So we are ready to transfer. And that's number 8. And then in number 9, it's where SATP triggers. So what we see in SATP core starts at 9. And then the whole protocol is executed. And when we are done, then the clients can go and check whether the transfer instance has been committed or rolled back, which are two termination states that are both valid. So they both know if the transfer went okay or not. Thomas?
Okay. You done, Dennis?
Yes.
Yes. I'll move the slide. So this is some questions. Okay, a lot of questions. I think this is just repeating what Dennis has just said. Like, I mean, for me, like, what does bind actually do? What does it look like, right? So, but I want to move on. I could go back to this. I want to move on to the next slide, which is providing an example. So Dennis, maybe you can run through this.
Sure.
Explain. Yeah.
So as you know, presented before in the flow, we talked about the context ID. Here it's a potential example of what a context is. So here again, as Thomas said before, we need to make sure that some things are immutable. For example, if we have a transfer instance, there is a context that defines what is going to happen inside the instance that has to have an immutable ID. So the gateways can go to this context. Eventually, that's where the registry might come in, because we can register this context in a registry in an immutable way and have an append-only modification of the context, so we all know what happens as we move in the transfer, in the execution of SATP core. So the context ID is an important one, and of course the status. So it could be in progress, could be aborted, could be rolled back, could be committed, for example. Now, there is a discussion about the sessions. Of course, there might be only one session if everything goes okay, but we may imagine that, and that's also something that Rafael said on the crash recovery, we might need to have several sessions until the end of the execution of the transfer. So here it's one way in the context to register all the previous sessions that eventually existed in one transfer. So here it's, for example, suppose that we had 2 crash and we are now in the 3rd session. This is an example of all the previous session IDs that are part of this specific transfer context instance. And then there is the egress part. So the outgoing gateway 1 and network 1, that's the egress part. And ingress, it's the incoming gateway 2, network 2. So let's dive into egress part. One thing that is important to set in the context is which gateway actually is gateway 1. So there should be an address somewhere of the gateway 1. And of course, there should be also a definition of the network 1. So that's the network 1 ID. The other thing that is interesting also is when there are entry points to the network, in which entry point we're coming in. So typically, if it's a DLT, could be an endpoint where we have to call in order to be able to enter network 1. So that might also be that we need an endpoint to access network 1. Then is the part related to the assets. That's what we're discussing before, that we need to list the type of assets that are participating in the transfer. So here it's an example of one asset with a specific ID. And as you could see there, besides the fact that we might need a URN for all these things, including SATP, in the asset ID, there is a part that is related to the network ID, and there is a part that is related to the specific construct that is managing the asset. So typically, the 0x89 here, it might be, for example, the smart contract that is managing the asset, for example. And just for the record, the network ID here is following the wages definition of network. So if I'm not mistaken, this might be Polygon, but I don't remember exactly. And of course, there is an expiration of the transfer, so we don't get stuck there. And if we would like to, have a time limit for the transfer, we might eventually define these and many other things that could also be required for the transfer. Now, on the to part, we need, of course, in the ingress, the address of the gateway 2, as well as the address of network 2 and the endpoint of network 2. So if you decode here what we have here, it's a transfer of one asset on the same network. So if you see network 1 and network 2 are the same, I believe. And we have two endpoints. Typically, this could be two different RPC entry points for the same network, for example. So this is just an example of what a context is and how we could eventually register that, typically in a registry or somewhere. But these are all information that gateways need to have access to at any point in time in the execution of SATP core. And I see questions about, Richard, where the context ID come from. I mean, this is typically the kind of definitions that we have to discuss and define in the context of SATP, because gateways, networks, context, sessions, and other artifacts need to have universal IDs, of course. Thomas?
So, and so one real quick.
Sorry, yes. Sorry, I'm busy typing. So, Richard, that's why we're having this discussion today. Where does this thing come from, right? Yes, good question.
Yeah, Wes.
One real quick mean share comment. That transfer status line is going to have a very specific enumerated list of possible values, of which in progress is one, right?
Yes, definitely.
Yes.
That's yeah. So this is the typical three-phase commit thing. So you can have, in progress, rollback, commit. There you are.
Dennis, I'm going to move the slide. I think what's the next slide?
Yeah. So
this is is rough. Like, what should we get at the end of doing all of this? This is before actual transfer, but at the stage 0.
Yes.
So
here it's like a
ahead,
condition. Yeah, like an exit condition here. So what do we need to have at the end of the of stage 0? So first of all, we need have a complete transfer context on the client side of the initiator of the transfer instance. So we have to have an ambiguous transfer instance with the context, say we are ready to go because all the various parties are referenced in the context. Then the important thing is also that at the network 1 level, the network knows that there's going to be a transfer. It's not that, it's passive in the sense that the gateway moves the protocol in the various. So the liveness of the protocol is guaranteed by the gateway. However, it is important to have network one know about the transfer context, because there might be competing transfers on the same assets. And if eventually we can think about, some optimistic or pessimistic way of locking the assets in the networks, typically is where the bit of binding of the asset to the transfer context is important for network one. Because at the end of the day, it's the network one that decides whether it's going to continue with a specific context, is going to, say yes or no, depending on on other things that might be in the negotiation of the transfer. If I get more money to go to the transfer, for example, instance one, it's better to give the assets there instead of the transfer context two, for example. And then, of course, the important thing on the gateway one side is that to know what is the counterparty. So what is gateway two? So we can execute all the steps of the protocol as defined in SATP core. On the gateway two side, of course, same thing. The client knows that the assets are going to come by the specific application client one. So we have a well-defined also transfer context on the receiving side. Same thing, that network two knows that the assets that are going to come, so it could be prepared to receive these assets on the incoming side. And gateway two knows about gateway one, so all the things that need to be executed in SATP are well defined here. So this is kind of exit condition for stage 0.
Okay, thank you. Peter has a question.
Right. Sorry for putting hands up a lot too much, but from this is actually some other information that might not be completely. This is just the information input. Actually, this is another assumption from a vendor perspective, a network device vendor perspective, because right now, like I can see all of those contexts that's completely reasonable, completely necessary. It's just right now, like there's no like consideration for the network, the IP network. This might be a little bit off topic, but right now in China, like we're building this, a large data element, like transferring network infrastructure that helps us accelerate those kind of asset transfer and data sharing. So under this under this situation, like the thing I would like to ask is that, because like when we are implementing the gateways, so usually these are the client will be for example 2 campuses or 2 companies that has this kind of a SATP gateway, and also at the same time is a CPE device. So there could be some kind of cross layer performance improvement or kind of coordinative mechanism. So the question here that I am not completely sure, but could be raised for some thinking, is that I don't know if this context could include or in any way include some network requirements or include some network information, the IP network information, or is that completely agnostic? I think that's just open for discussion.
Yes, thank you for the question. Sir. Yes, so the network, in the sense of what was used in SATP, it's a reference to the system that actually maintains assets. So it could be a DLT, it could be a traditional, multi-tier application in the Web 2 world. So that's what we are referring to as network. So that might be an ambiguous, maybe system is a better word, but anyway, I mean, this is a discussion that we might be having in the mailing list. The thing that you say about the physical now network on where to access is the thing that has been considered in the context as the endpoint. So there you could have information that is not just be a reference, but could be also a whole data structure on how we can access the specific, what we call networks or system in SATP terms, in order to be able to interact between the gateway and the system.
Yeah, I'll remind everybody that we sort of agreed a year ago or so to always call them asset networks to avoid the confusion, especially in the IETF, which is all about networks. I'll also note that
Absolutely.
while this conversation has gone on, I've written down two more future things that we need. One is a terminology document, and another is network and gateway location discovery, which I think we've talked about in the past. How do you discover where a network is and where the gateway for that network is?
So Thomas,
Okay, so yeah, let me. I think Dennis, I think we're good on this one. So next, let me move the slide. What's the next slide? Okay, so this is the proof of disablement. This is Rama's done work on this, but basically, once the app 1 and app 2 agree on this context ID, which contains asset ID, network ID, and so on, and gateway IDs, so that Dennis showed earlier in the example. So there needs to be a way for that asset in network 1 to be temporarily disabled, so there's no double spend, there's no people doing funny stuff while a transfer session is occurring. But like, how do we do this, number one? And number two, given that there's such a diverse set of asset networks out there, each with its own disablement technology, a locking mechanism in a particular, in Ethereum is going to look different than locking in, Avalanche or even Polygon, right? So whose job is it to deal with the variety of available networks? Is it Gateway 1, a Gateway 1 operator? So is there a network agnostic mechanism to extract this evidence, this proof, and report it to whoever is asking? In this case, could be app 1, right? And so, Rama, did you wanna speak up? I'll move the slide.
Sure, Thomas. Okay, so I presented a longer version of this particular slide several times in IETF meetings. So just want to talk about it in reference to what Thomas was talking about in as a need for stage 0. Just one word before that, the motivation for what I'm talking about here is actually spelled out in more general terms in the architecture document in the form of a data sharing or a data transfer interoperability mode between any two different networks. And motivating use cases for that have also been presented in the use cases document, one of them being the bill of lading example that Wes and Ori were talking about earlier in the session. There's a protocol which you can sketch out in very generic terms as how do applications discover the state of assets in either networks that are participating in a SATP instance. And we can narrowly use it, apply it for a particular purpose in stage 0, or we can apply it more generally to discover the state of assets in a different network, either within the context of SATP or even as a completely separate protocol. But in this context, just think of it as something that can be very useful in stage 0. What this requires technically is a universal communication format and mechanisms for applications to be able to fetch this information about assets via gateways. What do they rely on the gateways for? They rely on the gateways only for message routing and to be able to trigger actions in the networks, which SATP also does. Networks, if you have read the SATP specification, gateways are required to be able to send locking requests, burning requests, and creation of asset requests to the networks, which is of course out of the specification of SATP. The format involves how are you able to address a particular state that lies within a network. The network, of course, is opaque, but you have to be able to create a format that a gateway can understand, and the gateway can then interpret in order to pose the right query or trigger the right operation within the network that it is fronting. So there's an address part, and we have as a solution, we have a hierarchical way of creating this kind of address through gateways, networks, and the procedures, or in a DLT network, smart contract, and optionally you can have also a verification policy. So Thomas talked about proof. So proof is actually something which I've stated is optional, and also in the drafts it's stated as an optional thing, but really in practice it ought to be almost something that you use every time, because a proof is something that says whether it tells the requester whether or not this state that has been addressed and fetched from a network that lies beyond two gateways is actually authentic. And how the client verifies the proof, we leave it up to the client. What we are looking for here is just a structured way to describe this address, how to describe the state that is returned, and this general purpose request response protocol that will begins from the creation of a view of an address and the returning of some data along with proof. We have a couple of candidate drafts, one on the concept of views and view addresses. Why we call them views? This was a deliberate choice. We were trying to abstract out any network as a database. So the view is a term that's borrowed from the database world. Is just a way of addressing any particular data item that is guarded by that network without having to impose any kind of structure or obligation on that network. And the data sharing protocol, again, we call it data sharing. It may be an ambiguous term, but that's what we use for this request response protocol. And it's triggered by a client that is asking a question to a gateway. There's a publication we had back in 2019 that lays out the parameters for this kind of protocol. And we also have an implementation in Hyperledger Cacti, which covers a lot more than just the view addressing and the protocol between the gateways. That actually goes end-to-end, network to network, because we have to actually show examples of how this can actually be achieved. And in practice, the protocol has been applied in particular CBDC scenarios where you have two networks, one which maintains CBDC accounts and another which maintains digital assets like securities, and they both are querying each other using this particular protocol. So the diagrams on the right just show how you can this protocol can be used using gateways. Again, the yellow is meant to depict the protocol that we will specify in a hypothetical SATP data sharing protocol, which is the figure on the top just says a client is trying to ask a gateway, it's sending a view address to a gateway, and the gateway, if that view address just lies within the network that is guarded by the gateway, then it just returns the response, a view. Whereas in the figure below, it's a slightly more complex situation where a client is actually asking gateway to fetch a view from a remote network. So there, the gateway will pass the address and then figure out how to get in contact with a different gateway and fetch the view through that channel. So yeah, that's the overview of what I have here.
Is the
okay?
Can I interject for 1 sec? Sorry. Is the structure of why views are needed, which we've had this discussion before, is that outlined in your document and the SATP views addresses document of why there's an importance to have views? I understand that networks are very complex internally, and really you only want to talk to the gateway regardless of how complex it is behind it, right?
Yeah. I mean, we talk about why views are needed as a very general purpose abstraction of ledger state. And ledger state, not just a state, but also any kind of proof of authenticity that is that the party receiving the view can independently validate without having to know, without needing any other mechanisms or any other sort of direct access to the network that's supplying that view. So that's the motivation for having a generic format.
Understood. I just want to make sure it's documented well, so people.
Yeah.
Okay, thank you.
Yeah.
Thomas,
I think that's yeah. I think that's the end of it. Okay. Thanks, Wes. I think we're done.
Yeah, so I mean, we have a little bit of time if anybody has questions. I knew we actually had more time than we probably needed today by a little bit. So, does anybody have questions on the stage 0 overview that was nicely given? It's very complex, you know, so it's not a minor thing to bite off and take on. So, seeing none, why don't we go on to Haojin's presentation? Give me 1 second to make it work. Okay, should work.
Okay, hi. My name is Hyojin Song from Seoul National University. Yeah. And first of all, I have been interested in SATP just since at the end of last year. So, okay, sure. Okay, thank you. So please fix me if I understand something incorrectly in the explanation of this slide. Wait a second. And please also consider that most of the content are from my personal viewpoint as inclined to a specific use case and environment. So two motivation is the starting point on the draft. First of all, I remember a recent email in our group which describes the blockchain interoperability domain looks quite promising, but no one seems to require a standard for it. There are multiple proprietary protocols which can be deployed by a reliable service provider. The pure gateway can be a standalone service, so the need of standard might not be impactful in that case. But as far as I know, there seems several proof of concept experiments using SAT protocol, including me, but there seems a few real system or service using SATP for now. When I asked the reason to some people in Korea, they said the standard hasn't been completed yet, need more time for more stabilization, slow process of IETF, and something else. However, a national project like cross-border payments or other global cross-domain systems could require a global standard for its full coverage of interoperability. So in this background, I think the SATP is still the early stage in terms of its deployment status. The second point of this slide is that it would be great if we can secure multiple open source for SATP. Hyperledger Kaktai provides a well-organized SATP plugin, but it looks a bit heavy and requires some preconditions. If we can have additional SATP open source, especially as a lightweight one, it would be useful for several usages, such as a reference baseline for your asset transfer system, security verification, and other research purposes. In my opinion, SATP implementation guide draft could be helpful for providing a basic implementation guideline to facilitate both the mass adoption and more open source. I'm sure most of the members here are well aware of the status, so I'll skip this. But I hope the three major drafts are officially published as soon as possible for noticing it to the interested parties. Also, the other drafts looks quite important in terms of the reliable and interoperable SATP functionalities. And yeah, the big presentation would be inevitable if we don't deliver the other draft, such as stage 0 and message profile. The proposed draft currently provides a brief direction for now, but I'm willing to update it referring to the other draft in this group. So I need feedback from the authors of other drafts. I'm sure it would be useful for the target people here. And in addition, for a valuable and meaningful internal draft, I plan to develop a simple, lightweight SATP library at the same time, so that it can be easily adapted into a specific SN network. I personally thought the ownership of each gateway needs to be handled by the SN network, so it requires a pluggable and easy to extend structure that will be also described in the draft. I listed some questions or consideration in this slide, and honestly, I'm still not familiar with the previous history of the existing draft and SATP group, so I might miss some important points to be considered for the proposed draft. And I'll ask them to the group step by step if needed later. So please guide me if someone has an opinion about the direction of the draft. And probably I might provide more concrete content of the draft at the next coming meeting or mailing list. Okay, that's for the slide, and please raise some question or feedback on this slide.
All right, thank you very much. I will note that we have your item on the list of future things to talk about in terms of free chartering. So, but that doesn't mean that you can't keep working on the document, even if it doesn't end up in the charter directly for immediate entire working group use. Rama?
Yeah, sorry, just wanted to quickly remind people, or in case if you didn't know, inform you. I'd also mentioned this in when Hyojin presented his implementation in the last IETF. There are what he's been working on is, I think, the more mature implementation using SATP Hermes within Cacti. There is actually another implementation of SATP in Cacti using what are called relay modules, which are meant to function like gateways. So that's not as mature, but going forward, SATP will probably have two distinct implementations of Cacti will have two distinct implementations of SATP for as a reference for people. So, but yeah, thanks for presenting this, Hyojin. A quick question though on the draft, like if you specify implementation details, are you going to be talking about considerations for networks that must support SATP? Because then you'll have to talk about some details of network configuration as well, right? Or are you just sticking to how to implement gateways and maintain gateways?
Okay, thank you for the information. And yeah, right. The SATP gateway itself is quite simple and straightforward in terms of the implementation, but the point is that how to integrate the gateways and networks. So I'm considering some guideline how to integrate both entities in terms of the network administrator or manager. But yeah, I need to consider more in details. So yeah, I have some draft or overview of my thought, and I will share yeah, via GitHub or yeah, something other method.
Thank you.
Thank you.
All right, thank you. Any more questions?
And I have a question about what was said. You mentioned that the two independent implementation at the review previous. So I wonder if it's the mandatory one or required one in terms of the IETF policy.
That's a very good question. So different groups or even different areas have very different thoughts on that. Typically within the IETF, especially for new protocols, in order to really validate that the protocol is working well, if anytime you can prove that two implementations can talk to each other, right? In the web world, if web browsers didn't exist, it's sort of useless, right? You don't know if the web server is actually distributing information properly, let alone rendering it. For SATP, certainly it would be best if you could show that you were actually able to transfer an asset. When I first got involved in the IETF 20 years ago, we had interoperability tests where we would test every feature of a protocol. We would get two implementations together and say, okay, can you transfer an asset? Yes. Can you do a bidirectional transfer? Yes. Can you understand my context ID? Yes. And so that ended up creating very long checklists of these two implementations could work together. We're not quite as strict as we used to be 20 years ago. It used to be that the IETF had 3 different classes of standards, and the middle one you could only get after you proved that you went through, you tested every feature in a protocol. So we don't require it, I would argue, for brand new protocols, as Ori indicated earlier. What's the point in creating a standard if only one implementation exists? Right? The whole purpose of the IETF is to allow multiple implementations to exist. So
Thank you for the answers.
that's a good question. Thank you.
Yeah. Okay.
All right. Thank you very much. With that, we are at the end of the agenda, and we're into any other business. My guess is that we probably don't have any other business, but I will ask, does anybody have additional information or questions that they want to talk about today? Otherwise, we get 20 more minutes of eating snacks. Anything from you, Claire?
No, just a +1 on the eating snacks.
Okay. All right, sounds good. Claire and I will figure out what to do with our list of 14 something items to potentially consider. I will tell you my thinking right now is we're going to make everybody pick their favorite 3 and why they're going to implement them. And we'll figure out how that bubbles out. But Claire and I will chat about that next week. Not this week, Claire, I'm done.
No, fair enough. Fair enough.
All right, thank you everybody for coming.
Brilliant. Cheers,
See
everyone.
you in Madrid,
Good session.
hopefully.
Ooh, maybe.
Yeah, it's a maybe for me at this point, actually.
Wonderful. Cheers, guys.
Claire, yeah, actually, that's a good point, Claire. We should probably talk about having an interim between now and
Yes.
Madrid. Maybe May-ish would be a good time. So
I've got a note down in terms of booking something. Yeah.
thank you. All right.
No worries.
Bye, everybody.
Bye.
The acoustics up here are miserable. Thanks for the help on the notes.
I'm sort of in and out of it, trying to
Make sure that I jumped in usually when you weren't.
I want to make sure I understand the number.
I was impressed with your attention. This is not used to ADs, but you get much attention stuff.
Well, I've written smart contracts that code.
Oh, really?
So when I get your documents, if I can't see how they're going to work, you're not going to be nearly as mean to them as I will be.